The universe under acceleration, intercluster links lose throughput while bound structures persist. Local gravity wins, global connections lose. The rulebook stays, the background changes. Enter the force that taxes every span. The antagonist arrives, dark energy's quiet coup. While the network was optimizing itself, short paths, braided spans, feedback keeping arteries open, something else was changing the background rules. In the late 1990s, two teams led by Saul Perlmutter and by Brian P. Schmidt with Adam G. Rees, looking at Type Ia supernovae, measured how fast distant galaxies recede. Everyone expected a slowdown. Gravity should be tapping the brakes. Instead, the data bent the other way. Far beacons were dimmer than a decelerating universe would allow. Space wasn't coasting, it was speeding up. That pivot gave a name to the quiet force in the ledger, dark energy. Call it vacuum energy, a cosmological constant, or an unknown field. The effect is the same. As the scale factor grows, the average matter density thins, but dark energy keeps the same pressure and energy density. The tug-of-war shifts. Gravity still binds locally, deepening wells, thickening nodes. Meanwhile, expansion stretches the baselines between those nodes at an accelerating rate. Bridges get longer even as they try to carry the same load. Independent lines of evidence agree. Planck's CMB measurements plus bow from SDSS Daisy pin down a flat lambdictum universe with dark energy dominating the recent expansion history. Here's what that looks like when you stand on a filament. Gravity is pulling you downhill toward a cluster. Gas trickles along, sometimes in sheets that roll into threads, but the roadbed space itself lengthens under your feet. At first, inflow wins, you still make progress. Then, over cosmic time, the Hubble flow ramps up between the bigger basins. Past a certain separation, the throughput across the corridor falls. Not because the pipe is sealed, but because the upstream signal, gravity's invitation, no longer outruns the widening gap. It's like two towns on a single-lane causeway as the tide rises. The road is still there. The crossings get rarer, slower, then effectively stop. Stakes move from abstract to personal for galaxies on the margins. Closer to the nodes, redundancy and depth by grace. Farther out, single-lane spurs thin. Once dark energy dominates the energy budget, roughly the last 5 billion years, the balance tilts hard. Intercluster filaments don't snap like ropes. They diet. Their density drops as the background expands. With lower density comes weaker pressure gradients and longer cooling times, so less gas condenses into stars along the route. Starvation spreads from the bridges inward. What was once a two-way supply line becomes a memory of one. You can see the fallout in simulations and surveys that track infall rates and connectivity. Cluster growth continues, but increasingly by eating what's already inside their gravitational reach. The rate at which fresh material crosses the long baselines declines. The giant component of the network, the set of nodes mutually reachable within practical travel times, starts to contract in a useful sense, even if mathematically the graph still exists. That distinction matters. On paper, a path remains. In physics, the clock kills it. Meanwhile, feedback doesn't stop. AGNs still flare, winds still push, but their influence becomes local gardening rather than regional engineering. Jets that once could stir the corridor a few megaparsecs down now mostly shovel their own yard. The same energy budgets that once helped keep lanes open can't compete with the rising toll. The network rulebook remains valid, the price schedule changed. The result is ischemia written in comoving coordinates. Tissues, filaments, starved not by blockage but by distance outpacing delivery. Microstory. Think of a lone spiral galaxy parked near the lip of a filament that feeds a modest group. Early on, it drinks. Cold gas dribbles in. Minor mergers spice its disk. New clusters of blue stars dot its arms. Over a few billion years, the stream tapers. The galaxy still shines, still rotates, but the outer reservoir that once fed it retreats past practical reach. It mines its own halo for a while, then turns to older gas recycled by dying stars. The tempo slows. its future shrinks to what it has on hand. Impact cascades. Isolation grows first between superclusters, then between clusters, later between groups. Local gravity wins hard where it's strong, building thicker, more resilient organs. Global links lose quietly. The small world advantage narrows to neighborhoods. Average path lengths measured by travel time, not just by connectivity, stretch past meaningful. The network doesn't die, it provincializes. There's a temptation to ask for a single timestamp, the moment the coup succeeded. In reality, it's a gradient. But there is a threshold when dark energy becomes the dominant term, after which the direction is set. Paths that might have been maintained with modest mass now demand impossible subsidy. Bridges that would have been repairable under slower expansion degrade into ceremonial spans. From that epoch on, the future belongs to bound sanctuaries and whatever they can hold together. The quiet coup finishes without fanfare. No crack, no shudder, just acceleration turning every span into a longer bet. The antagonist doesn't break the web, it pulls it thin where it matters most. And that's why the next question is whether the universe stays connected. It's how much can be saved inside the organs that refuse to let go. The stroke hypothesis, percolation and the cosmic disconnect. To test whether a network is still one thing, ask if there's a giant component, a sprawling cluster most nodes belong to. Percolation theory says it exists only while a critical fraction of links stay active. Above that, signals cross in a handful of hops. Drop below and the body fractures into islands suddenly. That's the stroke. Translate to the cosmos. Picture nodes, galaxy groups and clusters, tied by filaments whose capacity depends on density and temperature. Let the Hubble flow crank up. As dark energy dominates, space between major nodes stretches faster, corridor density drops, and practical throughput. How much can cross within a Hubble time falls. Links don't vanish, they fall below usefulness. Percolation redefines connection from exists to arrives in time. Stakes for real places. While the giant component holds, metals mix across supercluster scales, outskirts get fed, mergers thread stories together, and radiation fields couple distant neighborhoods. When it fails, those processes stop at each island's shoreline. Inside, uniformity grows. Across islands, diversity fades. Civilizations needing exchange across tens of megaparsecs watch hard, become impossible on cosmological timescales. The critical point in a lumpy living universe isn't tidy, so simulations did the lifting. Grow a lambdictum universe, millennium, illustris TNG, trace filaments, measure link densities and travel times versus redshift. The key hint lands around Z051 when dark energy starts to run the budget. Infall from long-range reservoirs declines sharply, filament gas heats and rarefies, cooling times lengthen, and parcels crossing the longest spans rarely condense and deliver. Star-forming galaxies show reduced cross-filament synchronization as environments decouple. No single blow, just roots fading below functional thresholds almost everywhere at once. At supercluster scales, the giant component defined by reachable within an epoch collapses into bound basins. Inside each, paths stay short and dense. Between them, path length measured in years diverges. A line may exist on a map, but the cost to traverse it exceeds any physical budget. In percolation terms, the occupation probability of effective links fell below critical. The spanning cluster is gone. Early time percolation during reionization was bubbles of transparency touching so light could run. Late time percolation is its mirror. Bubbles of inevitability, bound regions, becoming the only places where exchange stays real. The web becomes a jar of organs, each stable, each aging on its own clock. Observables track the shift. Cluster mass growth pivots from smooth accretion to mergers of already bound halos. Clear filamentary inflow signatures decline. Metallicity gradients flatten locally and diverge globally. Galaxy alignments with parent filaments weaken at the largest scales as distant torques decouple. Same symptom, different instruments. The orchestra lost its conductor because sound can't reach the back row. Don't circle a single day. Think an epic when the last trans-island spans slip under. Some reconstructions place the practical threshold near when dark energy dominates. Stricter, deliverable definitions push it later. Either way, the arrow points one way. Past that window, no routing restores a giant component across cosmic scales. The universe keeps a web on paper and loses a web in practice. Microstory. Across a supercluster bridge that once carried dwarf groups toward a rich node, a final trickle of cold gas drifts, stretched, heated, and bled thin by the ride. It reaches the midpoint and fails to cool. No stars will light that causeway again. Both ends keep living, even thriving, but they'll never share a season. That's the pivot downstream. If stroke equals disconnection, the next system to suffer is memory, the lived history a network writes by mixing, feeding, and exchanging. The ledger turns local. The archive fragments. The universe won't go dark tonight. It will forget how to talk to itself. Memory in a universe, how the cosmos remembers. If disconnection is the stroke, memory is what fades next. Not memory like ours, but the ways the universe records its own past. Every galaxy keeps a diary in matter and light. Read it right, and you can hear the episodes. Who fed whom, who collided, who went hungry for 1 billion years and then finally ate. Start with metals. Stars forge heavy elements and scatter them. The pattern they leave, metallicity, maps the meals. Cores of big galaxies are rich because they've been fed, stirred, and refed. Outskirts are poorer when supply lines are thin. Stretch that across a filament and you catch the ghost of trade. Gradients smoothed by exchange, sharp edges where traffic died. Metallicity is memory ink, diluted by mixing, deepened by bursts, frozen by isolation. Stellar populations tell time more bluntly. Old, red, alpha-enhanced stars mark fast early feasts. Young, blue clusters flag recent deliveries. Stack a galaxy's stars by age and chemistry, and you get a barcode of its inflows, outflows, and close calls. Quench a corridor and late arrivals vanish from the record. The barcode ends with a long, quiet band. Black holes keep more private notes, but they're legible. A supermassive black hole's mass and spin encode the tempo of accretion and the violence of mergers. Long, calm feeding leaves a different imprint than a chaotic sequence of random snacks. A line spins and you've likely got a history of steady inflow along a preferred axis, often set by a filament. Scramble them, and you're reading a life lived at junctions, where directions change and partners arrive from every angle. Then there are the structures that act like file systems. Streams, thin rivers of stars stripped from dwarfs, wrap halos in looping cursive. Their thickness, coherence, and chemical tags remember the orbits of the accreted and the gravity they felt. Shells mark radial collisions. Warps whisper about torques from neighbors you might not see anymore. Even the shapes of disks, barred, flocculent, grand design, depend on supply rhythms and perturbations. Morphology is the short story. Kinematics is the underlined passage that tells you why. Entropy is the background ledger. Hot, well-mixed gas at cluster centers is high entropy, the end of many stirrings. Low-entropy pockets trapped along filaments signal cooler inflows not yet erased by shocks. Map entropy in X-rays, and you trace which routes stayed open. Watch those pockets fade as distances win, and you're watching the archive compress into sameness. The cosmic microwave background holds the prologue, tiny temperature ripples, polarized patterns that record the first sound waves. On smaller scales, the Sunny Zeldovich effect adds late notes, hot gas scattering CMB photons, announcing that clusters formed here at this time with this pressure. Stack enough clusters, and the SZ statistics become a census of late heating, the universe's marginalia. Isolation edits all of this. Cut off fresh gas and star formation skews old and metal-rich, not because the universe ran out of atoms, but because recycling dominates. Dying stars return material to the interstellar medium, but it's tired fuel, enriched, often warm, slow to cool. Without outside dilution and pressure, the next generation looks like the last, only dimmer. Diversity shrinks. The plot narrows to epilogues. Microstory. A starving dwarf at the end of a fading spur carries two tails in its body. The first, a burst of blue a long time ago when a wave of metals from upstream finally reached it, triggered cooling it couldn't do alone. The second, a gentle, stubborn trickle of red giants forming from recycled gas, century after century on cosmic scales, because nothing new ever arrived again. Its spectrum is a farewell letter written in two inks. Memory also lives in alignments and spins. Galaxies tend to point and rotate with respect to their parent filaments in ways that reflect early angular momentum transfers. That coherence is a fossil of tides from large structures. As links stretch and weaken, new torques fail to synchronize distant neighborhoods. The old alignments persist inside islands. The cross-island choir drifts out of tune because no conductor's downbeat reaches across the gap in time. Even the statistics of mergers mutate. When the giant component was lively, minor mergers streamed in along many directions and the catalog of orbits was varied. In isolation, the supply becomes whatever was bound already, satellites on fixed families of paths. The future's archive gets repetitive. Fewer rare events, more echoes. Zoom out and you notice something sobering. Information in the thermodynamic sense tends toward erasure as systems thermalize, but structural information, arrangements, gradients, and isotropies, can persist for a long time if you stop stirring. Isolation paradoxically preserves some chapters by sealing them, while erasing the library's cross-references. You can still read a galaxy's past within its halo. You just lose the paragraphs that connect it to a neighbor's fate. This is why percolation mattered so much. While bridges carried influence, the cosmos wrote a collaborative book. After the threshold, every island writes a memoir, beautiful, detailed, and incomplete. And if you care about consciousness riding inside any of these structures, that narrowing isn't abstract. It constrains futures. It confines meaning to local shelves. The universe keeps remembering, just less of each other. Consciousness on borrowed time. So where does that leave thinking things, us, nested inside this fading web? Start with a simple stack. Neurons form brains, brains build societies, societies build infrastructures that stretch across star systems, all nested inside galaxies braided by filaments. It's networks all the way up and down. When the macro network thins, everything inside it inherits the constraint. Ambition becomes a geography problem. Civilizations live on logistics, not poetry supply lines. Interstellar projects need propellant, metals, energy beaming, time coordination, and redundancy. Intergalactic projects multiply that by distances that punish every inefficiency. While the giant component held in practice, there was room to dream big. Harvest gas-rich dwarfs, skim cold flows, trade elements across neighborhoods, map and mix. As those links slip under the percolation threshold in usable time, the menu shrinks, not to nothing but to local. Here's the catch people gloss over when they imagine Dyson swarms and Kardashev climbs forever. Horizons aren't metaphors, they're rules. As space accelerates, the event horizon tightens around what will ever be able to talk to us. Resources beyond a certain radius are, for our purposes, already gone. The expansion doesn't steal atoms from us. It steals coordination. That difference sounds academic until you run a mission plan and the signal you need can't arrive before the clock runs out. The window is not static.